All right, good day. My name is Julius Ibenagum Juliben, okay, Chukwu Ibenagum, yeah. I happen to be a student from the Nnamdi Azikiwe University, and I'm running a PhD program in Unizik. My supervisor is Professor K.R.E. Okoye, and I had this dream of designing a generator that actually does not make use of fuel, it does not make use of oil, it does not make use of water. In fact, it's a fuelless generator. It's carbon free. Carbon free in the sense that it doesn't produce carbon monoxide. Last time in the news we overheard the death of students as a result of carbon monoxide coming out from a gen just positioned at their window while they were asleep. They slept off and never woke up. So I have been thinking of a generator that cannot make use of fuel, oil, water, as the case may be. And this project work has been on ground for over almost 10 years now, and at this PhD level I decided to actualize it and make it a reality, and I pray it goes through as in partial fulfillment for my doctorate program. So very briefly, I will introduce the different components that makes up this fuelless generator. And first we have here the armature. This is the armature, also called a rotor. This is what rotates within the stator winding. And then what we have here is this is the coil. Yeah, this is copper coil, also called stator winding, and this is what actually receives the rotation of the armature within. And then we also have another component here, very importantly, the DC motor. Yeah, this is a DC motor. I think it's written somewhere there. May be able to see that clearly. I think it's a little bit dark. So it's a DC motor, and this is a DC motor of 3,500 revolutions per minute. It's 2 horsepower and can be powered by a 12-volt battery. And then we also have a circuit breaker, just in case anything happens and there is need for the system to shut down to avoid damage. We have a circuit breaker here. And then we also have a capacitor here. This is a 24 microfarad capacitor. And then we have a 4-corner diode. It's quite very small. It's a 4-corner diode. And the essence of this is to rectify AC current into DC current. And then we have some cable wires which we're going to use. And then these are clips for the battery. And then of course we have a 12-volt battery. That's quite a little bit big. It's a 12-volt battery, also called a car battery, which we are going to use in the process of the whole design. So these are the basic components we have here. Okay, we also have a multimeter. However, the multimeter will help us just to confirm certain voltages and confirm if our equipment are in order and the amount of power dissipated. Alright, so at this point we have to go to the theoretical part of how this amazing fuelless generator works. So having discussed the theoretical part of it, we are going to go straight into the coupling process. That is a practical work, and see how really it works. So theoretically speaking, this concept of fuelless generator is based on the principle of electromagnetic induction. Yeah, the principle of electromagnetic induction introduced by Michael Faraday over 200 years ago. Michael Faraday in his experiment made us to understand that if you have a magnetic field and you bring a tiny piece of wire inside that magnetic field and you move that wire to and fro, there exists an induced EMF within that system, and that induced EMF is electric current. That is Michael Faraday's principle. He performed series of experiments to come up with this, and then of course when this experiment was finally achieved and it was a successful one, different varieties of machines, different varieties of electrical machines were produced. So the same concept is what is applicable here. So in this stator winding, you have multiple wires, copper wires, which are coiled into different coils. The higher the number of turns, the higher the capacity of the electric currents that will be produced. So it is turned into multiple coils, and this on its own is already a magnet. Yeah, it's already a magnet, because whenever a particular single wire is wound into a solenoid, a magnetic field is set up into that wire. So this is already by default a magnet. This part of the magnet is called the stator core, and this stator core actually its job is to absorb flux that will be generated within this magnet. Now, This is the armature. The function of this armature is the rotating part of the engine. This is the stator winding. It is stationary, it doesn't move, but this one is what will rotate within the particular stator winding. Now the rotation of this one within the stator winding is what brings about the electric current, because as it rotates within the stator winding, it cuts into the magnetic field generated by this stator winding, and electric current is generated. Each time it rotates, at a point it will make an angle of 90 degrees to the magnetic field generated by this stator winding, and at that point flux is maximum. As it turns within, what happens is that the flux begins to decrease at a factor of B cos theta. B is the magnetic field, so it keeps decreasing until it becomes parallel to the magnetic field produced by the stator winding. At that point where it is parallel to the magnetic field, flux is minimum. And if you draw a graph, it will go up and then come back to the line at 0. And then from there, it will pick up again in the negative direction. And that is why the graph of an AC curve is sinusoidal in shape. So the change in flux is what brings about electric current. Change in flux is what brings about electric current. So as it keeps turning, what happens is that flux continually changes off and on, and then electric current is being generated. Now, if you want to determine the direction of this electric current generated, Lenz's rule becomes very important. Boom. So Lenz's rule made us to understand that the direction of electric field inside the stator winding is in the opposite direction to the flow of current initiated by this rotor that rotates within the station winding. In other words, if the current is coming this way, the electric field is coming in the opposite direction. And that is Lenz's rule. And if you check Lenz's rule properly, Lenz's rule is in accordance with Newton's third law of motion. Force and reaction are equal but opposite to the direction of field lines. And then also it's in accordance with the law of conservation of energy. The total energy formed from within sum up to a constant. Now, Fleming's right-hand rule is also very important in determining the direction of the current produced. According to Fleming's, he made us to understand that when the thumb, the index, and the middle finger are mutually arranged to each other, such that each of them are at 90 degrees to each other, this one pointing in the direction of force, and this in the direction of the magnetic field, then the middle finger will point in the direction of the electric current induced in the system. That is for AC. As for DC, Fleming's left-hand rule will do the job. So the direction of the current induced will be still the direction of the middle finger. Now, this design can give you AC, it can give you DC, depending on how you manage the induced current within the stator winding. The rotation of this brings about induced current into the stator winding, which we use at home. Now, how you manage the induced current will determine whether it is AC or DC. Now, this setup is for an AC setup. Why? Simply because the current is allowed to alternate as the flux continuously changes. That's why you call it alternating current. But for a DC motor, the current is not permitted to alternate. The current is permitted to flow in one single direction. And the help of that is by the use of commutators, or simply put, split rings and brushes that will help maintain one direction flow of current. So current will flow in one direction within the magnetic field set up by this stator winding, and at the end of the day, what comes out of it is DC current, direct current. And that is what you see in this setup. This is a DC motor. That's exactly what happens within here. So if you rotate this particular shaft on this DC motor has the ability to output 12 volt worth of power, of watt of voltage from these terminals. Same thing works with this particular stator winding and rotor. By the time it rotates freely from inside, it's going to induce current here, and the current that is going to come out is AC because we have permitted it to alternate. Now, if you check very well, they have different colors here. I hope you can see that very well. This is the red color. The red and the black color you see here, there are 6 terminals that comes out from here, 6. The red and the black terminals you see here are the ones that will go directly to your changeover. Then the 2 brown colors you will see here are the ones that will be used to charge the system. That is to say, to recharge the battery. That is this battery right now. And you can connect a 4-corner diode here so as to convert the AC current that is going to come out from this stator winding as a result of the induced current from this rotor. Then you convert it to DC that will be able to charge this battery. And then the other 2 wires, which are orange in color, hope you can see that very well. These 2 orange in color wires will be connected to a capacitor. And the function of that capacitor is to simply store energy that is required for the alternator to output the 220 volts to 240 volt required for AC current. So basically, that is the theoretical part of this setup. Now the next thing we are going to do is to go into the coupling process. We have to couple everything and see how this can produce current for us to use at home without fuel, without oil, without water. It sounds a little bit unbelievable. How can we couple all this and it gives us power? Yes, it is possible and it will definitely happen. So let's go into the practical proper and let's see what comes out of it. Rotor. So I pick the rotor. I will slot the stator winding just within the rotor, and then I'll pick this cover. Now take note, the cover has a slot here, and the essence of this slot is for you to have this terminal output. And then also you have to be careful so that everything matches exactly as it is supposed to be. So once you do that, you fix that properly, you will need to apply some kind of hammer here so that it will sit. Alright, so now it has sat and is able to move freely. The next thing I'm going to do right now is to introduce the other part of the casing. So I have to sit this up and bring the other part of the casing. Alright, so having positioned the base, now is to put the casing, which is this one. And of course, when doing that, you have to ensure that it tallies with the correct settings so that you will have maximum output. But before then, you have to use this stator core cover. This one covers the stator core that you see here. It doesn't really have a function, it's just for aesthetic purpose, nothing else. So once we fix this stator core cover, the next thing is to So the next thing we have to do now is to bring this shaft. This shaft was separately produced. We had to cut this from the mechanical part of the engine, the crankshaft. So we have to remove this and then cut weld to form this. Please watch the video on how this was done. We take this and then we have to pass this through here, and we're going to use this bolt and nut to be able to do that. This comes with an internal screw from inside, so you can actually screw this and it just sticks together. Okay, so this is what will connect this DC motor to this alternator that we have set up all the way. So the next thing to do is have this inside and then prepare a way for this to go through from the back. Ensuring you do not alter the settings because everything has been set already. So I'm going to fasten it from the back here Let me rotate this a little. Okay. So with this, I can get what I want. I can turn this properly and ensure that it's firmly tight. Please, this has to be firmly tight because this is the rotating part of the AC generator. So you can use, it's a 13-volt spanner. That's firmly tight. So at this point, the next thing that we have to do now is to get this generator a house, getting a fitting, a setting that will be able to carry this particular DC motor. Now, the revolution of this DC motor is 3,500 revolutions per minute. It is a 2 horsepower DC motor, and it's powered by 12 volts. So the voltage that will power this DC motor is the battery you see here. This is a 12-volt battery, 75 amps. It can be powered by 25 amps, 50 amps, 75 amps, 100 amps, even 220 amps as the case may be. So long as it is 12 volt, it can power this. The rest are just the capacity difference. So this DC motor is now going to do the mechanical work that the generator where you put fuel, water and oil is supposed to do. That is what this DC motor is going to do. And for this DC motor to be able to have a proper fitting here, because one must be very calculative, for this DC motor to be able to have a proper fitting here, first we have to introduce this nut here. The function of this nut is to be able to hold this DC motor shaft so that it doesn't pull out during the course of rotation, because a lot of energy is dissipated while it is rotating. So by mere having it into this slot is not enough. So there is need for this 10 volt you see here. And the 10 volt you see here is designed such that it can sit properly in this hole. We have to drill a hole here. So once the bolt goes and sits in there and you tighten it firmly, this motor becomes very, very impossible to be pulled out during the rotation process. So that is what will happen. So that for that to happen, we need a proper fitting that will hold this particular alternator now, and that will hold this DC motor in position so that they will just be at the same angle to each other. It shouldn't be inclined, it shouldn't be over high, it shouldn't be sideways, it should be directly into it so that no energy will be lost through friction. Because if it loses position, energy will be lost, and at the end of the day, it won't be able to function effectively. So we are going to show you a video of how that is designed shortly. Please watch the next video. So now we are going to start with the coupling process. So first, this is the framework of the Fuelless generator. I have to choose stainless because of the way stainless materials behave to noise and how resistant they are to corrosion and all that. So first, this is the inside. Everything designed to suit the Fuelless gen. These two slots here are to carry the alternator, that is the rotor and the stator, and then these ones are to hold the DC motor. It comes with holes here where you fasten the nuts for the DC motor, and then this is the battery carrier. So the battery carrier will be here, and then what you have here are slots. This is for the AC output, then this one is to hold the diode, this one is to hold the capacitor, these holes here are for the circuit breakers, and then here will be for the charge controllers. This is the front view of how it looks like. So let's start the coupling process immediately. Boom. All right, so let's start with the coupling process. I think the first thing is, let's plug the battery. This is a 12-volt battery, 75 amps. So we'll put it here. Let's take it this way so that it will fit perfectly with the wiring process. Okay, so that's a 35 amp battery. I said 75 amps 12-volt battery. So the next thing we are going to put is the DC motor. So the DC motor already comes, we have screw here which you can actually lose and then fasten them into the design nuts already. We're going to use two. So we're going to make sure that these two terminals are going into here, and all right, so that's firmly positioned, very firm. So at this point, the next thing we're going to do is to bring the armature and coil and position it such that this hole, okay, let me lose this first, and position it such that this will fit into the hole created here. So let's do the gutter positioning. Then I'll use spanner to guide it very well. Should be properly guided, because if it is not properly done, it may pull out in the course of rotation. So we have to screw and ensure that the screw gets to the end. Perfect. So now the screw has gotten to the end. Any rotation that comes in from here will just go perfectly. So at this point, the major components are already here. This is the alternator, this is the DC motor, this is the battery. So now that they are in position, okay, I need to fasten the legs of this. Very important, because this will also vibrate as things are going on. These rubber materials will be very useful to absorb vibrations coming from the alternator. So we are going to double for each of the legs, since there are two legs on the alternator, and then put this rubber material to absorb vibration. Just underneath here, this is the bottom, these are the legs. So we lift this and put it, and do the same thing for this side. We are going to lift this and put and double them to absorb vibration. So haven't been able to fix it, the next thing is to screw it from the back. We had to fix here as well, so let's do the screwing. So we start the wiring process, so everything is perfectly done. This is strong, and this is as well strong. So for the wiring process, we are going to use this wire and socket it here. And then of course red black is to red black, orange is to orange, and then the brown we go with these blue colors you see here. So once we socket this in, perfect, so it has clipped. These two wires will be going to your changeover, which here I'm going to connect to this two-way socket, and then the blue wire you see here will be going straight to your diode, so that you can convert AC to DC, and the AC to DC will now be used to charge this battery while the gen is running. And then this one will be connected to the capacitor, that is this orange color cable. It will be connected to the capacitor, so the capacitor will store enough energy to be able to produce 220 volts or 230 volts as the case may be. And this is the capacitor we are going to be using. That's a 24 microfarad capacitor. And then you're also going to use this 4-corner diode. This is about this is a KSPC3510 diode. And if you check the terminals of the diode, you have positive and you have AC. So these are the orthogonal, or let me call it diagonal now. The diagonal, this positive sign you see here indicates that this is the positive terminal and this is the negative terminal of the diode. While these two other ones, you will see AC by this side written. Hope you can see that properly. So the AC you see here is actually telling you that the diagonal terminals of this diode are the AC that is coming out from here. So this DC, the major function it's going to do is to convert the AC current coming from the alternator into DC current that will be able to charge the battery. That is the function of this. If we do not connect a charging system to this battery, in the next 30 minutes, 1 hour, depending on the capacity of the battery, the DC motor will run down the battery. So the battery needs to be continually charged while it is being discharged to give you power. Alright, so we are going to connect this right away. Connect this and other part of the job. Tight. And the next one is the charge controller. So this is what is going to be charging the system. Then we turn it on from here. All connection must be neatly done. to avoid any form of short circuiting. All naked wire must be insulated so that you have a clean setup that will be free from any form of short circuiting. So now the connection is properly done. Everything is properly connected at this point. The only thing remaining now is to connect the charging system for this particular solar. Now the essence why we are bringing a charge controller and a solar system for this particular charging of the battery is because from the experiment work I've been doing, I've noticed that the charging system that is coming from this AC, or the rate at which it is charging the battery, is not equal to the rate at which the battery is discharging to charge the DC motor. In other words, if this is charging the battery 20% for every 1 second, this is drawing 30% for every 1 second. So a time will come the battery will die. If the charging rate was equal to the discharging rate by the DC motor, then this system will run forever and it will never go off unless you come and put it off yourself. So but the charging rate is slow compared to the discharge rate. So on that note, there is need to connect another system of charging that will perpetually charge the battery even when the gen is not in use. And that is how I came up with the idea of using a solar. So that is how I came up with a system of charging it through the solar system. So the solar system will be able to perpetually charge this battery even when you are not using the generator, or when you are using the generator, it is charging, and we always keep your battery full 24/7 depending on the capacity of the solar panel you use. We are going to demonstrate the connection of the solar panel soon, and then you see how everything is properly connected. So if the solar panel is there, it charges your battery from morning to afternoon, it's full. In the evening you come and discharge it for 4 hours, 5 hours, 6 hours depending on the capacity of your battery, and it continues like that every day by day, thereby saving you fuel, saving you the cost of maintenance, and as well the cost of buying oil and all that. So the next thing remaining for this setup to be fully complete is to connect the solar panel as an extra means of charging this battery. And we have a charge controller here already, and this charge controller has here slot for the panel. If you check that, there's positive and negative. Here you have the battery. It's a little bit faint. Okay, that's clear enough. You have a battery, positive and negative terminal. Here you have the DC load. So this area of the generator is going to give us DC current, while this will give us AC current. All right, so if I put on this particular part of the circuit breaker, is for the solar system. So if I put this on, you see it has come up. All right, so now it is showing 12.7 volts, which is the voltage of the battery. Now the battery is at 2 bars, about 0.5%, that's 50% charge right now. So the input you see here is 00 because I have not connected the panel to it yet. And then the output here is 00 because I have not connected any output yet, any DC output. I can get a DC bulb, a DC fan, anything that makes use of DC, and connect here so that I can have access to DC current. All right, so very shortly, let's connect the solar panel. We are going to be using this as a stand for the solar panel, just for demonstration purpose. It's not going to be here permanently. It's just for the purpose of demonstration. Or I can turn it over to this side so that it can receive sunlight. Although I'm within the office right now, we may not have 100% sunlight here. So, but let's get the panel. We're using this is a panel. This panel is 50 watts, and the voltage of this panel is 18 volts. So this is the panel we are going to use for the setup and the construction process. So now the panel has been positioned. As I said before, it's just for demonstration purpose. This panel can be taken to the top of the roof where it will isolate solar energy and convert it to DC energy that we charge the battery. So these are the terminals of the panel. There are 2 terminals. The red is for the positive, while the black is for the negative. So I'm going to connect them straight here for the panel option, which is positive and negative. And by the time I do that, this should be able to take the reading of the panel. All right, let me quickly do that. All right, so finally I've connected the panel. So it's inside the office right now. And then this is the cable running down into the gen and coming out from here. So this is the positive terminal to the positive of the panel. Then the black is the negative terminal. That's this black one. It's a negative terminal to the negative part of the panel. Then I had to connect a load, positive and negative. I had to connect a load, and which is this fan. This is a DC fan. So we're going to see how this can supply that particular voltage to this DC fan. Alright, so first is to put it on from here, and this will come up. And what is reading here right now is the voltage of the battery and the voltage of the solar panel. So the solar panel has peaked already. That is this one. That's the panel here, and then this is the voltage. Now the load is still showing 00, and the reason is because we are not using the load yet. For us to make use of the load, we can press this menu or this off and on button, I want to say, and it's blowing very well. So, and currently the current is 4.15 amp. It's varying. So that is that for this. And if I want to turn it off, I will just click here and everything will go off. Everything will go off. But this is supposed to have its own personal switch. That's for load. Assuming you have to have DC load in your house, you have its own personal control switch. If you want to turn off everything, you come over here. To put on everything, you just do it from here as well. And the fan will just be, and it's blowing just very fast. So this is the DC source of the whole generator. So you can have DC on this aspect. Now we'll go to the AC aspect. So with this, you can even charge your mobile phones through these slots you see here. It can charge a minimum of 4 phones at the same time, a maximum of 4 phones at the same time. So you find them here. These are USB sockets, and they are rated 5 volts 2 amps 5 volts 2 amps, so it can charge your phone battery easily and very well. So the next part is the AC part, which is the AC current, which you can take to your changeover from here, and you power your home entirely. So we are going to put on the generator. Everything is properly connected. So if I put on this here, it will start rotating, and boom, you will have power. So let's give it a try. Now you see the rotation. Everything is working perfectly. So now I'm going to put on the switch here. It's on. Woohoo! This is magnificent. Now you can see it's giving you full power, and it's working just perfectly very well. You can also on this at the same time and put on this, and all of them are working just at the same time. This is an edifice on its own, a masterpiece par excellence.